In this video, we have a look at how the gradient of a line ties in with the angle that that line makes with the horizontal axis. Let's consider this example with a line and angle theta between the line and the x-axis. What we'll do first up is we'll create a triangle so we can determine the size of the angle. We could then work out the length of some sides in the triangle. For example, we could work out the side opposite the angle theta and the side adjacent to the angle theta. Having opposite and adjacent allows us to form the trig ratio for tan. So tan of theta is equal to the opposite over adjacent. But also in that triangle, we know that gradient is the rise over the run, which you can also see within that triangle. So rise replaces opposite and run replaces adjacent. And rise over run gives us the formula for the gradient of that line. So essentially, tangent of theta is equal to the gradient of the line. Let's have a look at some examples where this can be applied. The first one is asking the question, what angle does the line y equals 2x plus 3 make with the positive x-axis? Well, we know from the basic form for the equation of a line that the coefficient of x in this case is going to be the gradient. So the gradient of this line is 2. We therefore know if we call the angle A, the tangent of the angle A, which the line makes with the axis, is equal to 2, because it's the same as the gradient. Let's have a look at a diagram to see what this actually looks like. The first thing to note is that our equation y equals 2x plus 3 indicates that the y-intercept is 3. And we'll notice that the angle that the line makes with the x-axis is on the right-hand side of the line. That's because we talk about the angle with respect to the positive x-axis. So when we're using the fact that the gradient is the same as the tangent of the angle, it's the angle on the positive side of the line. In other words, if we head in that direction on the x-axis, we head towards the positive numbers. And we can see that there with that green arrow. So the angle is on the right-hand side. So tangent of A is equal to 2 because that's the gradient. Now what we need to do is solve that equation. And we do that by using inverse tan. So the angle is equal to tan to the negative 1, or inverse tan of 2. And when we solve that in a calculator, we get that the angle is approximately equal to 63.43 degrees. Let's have a look at another example. This time the line is expressed in a different format. So what we want to do is find the angle that the line 2x plus 4y equals 8 makes with the positive x-axis. So what we need to do first of all is rearrange our equation so we can get it in the format of a gradient and a y-intercept. And we'll do that by first of all shifting the 2x to the right hand side, so it becomes subtract 2x. Then we divide everything through by 4 to remove the coefficient of 4 next to y. And we know that the basic format for a line is y equals mx plus c. We want to get the term with the x at the beginning of the equation, and we simply do that by swapping the negative 0.5x and putting it to the front, and the positive 2 we put to the right hand side. So our equation of the line is y equals negative 0.5x plus 2. So in that case the gradient is negative, and we can see in our diagram here that we have a y-intercept of 2 and the gradient is negative 0.5 or negative a half. So what we do to find the angle, which is on the right hand side of the line, in other words on the positive x-axis side, is we let tan A equals negative 0.5. Then to solve for that we take inverse tan of negative 0.5 and we then get an answer of approximately 153.43 degrees. Now your calculator when you solve that may give you an answer of negative 26.57 degrees. We need to keep in mind that our angle, and we can see it from the diagram, is going to be an obtuse angle in this case. So our solution is found by going 180 minus 26.57 degrees to give us 153.43 degrees.